This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Alright, let's start with the second class. So, you remember this maximum minimum stuff of quadratic functions, and remember those 5 formulas that we wrote. Okay. So this is going to be our third formula, and those two you might say are our fourth formula. Now let's go how we're going to do this stuff in programming. Let's go to the polynomial folder that I sent to you and copy paste all of the files inside of the header and CPP files. Copy paste, so copy them and paste them to the solution folder here. I already did it, but I'm going to replace it here. And afterwards you just go and add existing item and add poly CPP, polynomial CPP. This is going to be our main. We should need some random generator number here. And string utilities. So those 7 actually. 3, 5, 7. You'll need those 7 files. Add them and put headers to the corresponding header section and source files, CPP files to the corresponding source files. From the string utilities, here we are going to use only this function, itoa, which is doing basically, as you might remember, it is converting an integer to a string. You take an integer as a parameter and you return it as a string. Now we are going to use this itoa. Then you remember the random generator function. Basically from this guy, we are going to use only the function that we already saw during the last lecture, random integer number. Okay. We're going to, for coefficients a, b, and c, we're going to use this guy here. And now let's go and explain the polynomial class. What do we have here? I'm going to erase those graphics. Let's go with the polynomial class. So, we have class. What was the name of the class? I think it's poly, yes. Okay, class poly. This is capital P. Our private data first. Private data, cannot see them here, but yeah, private data are coefficients a, b, and c. We call them my a, my b, and my c. If you have a, b, and c, basically the polynomial, in our case this polynomial is the quadratic function, is completely known. Okay, public. We have the constructor, which is named poly. Okay, you know the constructor is the first function that is being called when we defined a variable of the type poly. So the constructor is part of this guy. It's poly a, b, and c. What is this guy doing? Let's see the corresponding CPP file. So when we call the constructor, when we give parameters a, b, and c, those private data take the values that we send. Basically, my a becomes a, my b becomes b, my c becomes c. This is it. Very simple. The other function that we have in poly is the extreme value, and it returns a double. So, extremumx. Okay. Let's see what is this guy doing. The extreme value x, it returns this stuff. You know why? Because the extreme value, when we took the first derivative, was b minus b divided by 2a. So we return this value. Now extreme y, in order to find y, we first should find x, of course. That's what we call extremux. X is equal to this function. And afterwards we substitute the value of x in the polynomial, which is a x squared plus bx plus c. Okay? And we return this value. This is extreme y. So this is the third formula basically. We substitute the second formula to the first one. We saw it on the boards. This is how we find extreme y. Then we have what? Min-max. It returns a string, as you can see. And min-max tells us whether the extreme point that we have found is a minimum or maximum. Okay, so let me write it also. This is extremum y. We saw it. And what do we have else? Min-max. Another function that tells us whether the point, the extreme point, is a maximum or minimum. It returns a string. So you remember that when a was greater than 0, we had the minimum. That's why the result is minimum. Otherwise, when a was smaller than 0, we had the maximum. So result is initialized as maximum, and we return the result. Okay, so this is min-max. And finally, there's the function called toString. So we have this function, toString. And what is this guy doing is the following. It returns the polynomial as a string. Okay? So if we have we want to print something like this. Let's say 3x squared minus 2x plus 3. If you want to print it like this, and if you want the computer to take this as a string, we're defining the function toString. And this is a very famous function, especially in C#, since, as you already know, every other type can be converted to string, double, integer, whatever. It can be seen as a string. So this is the case with the polynomial function. So let's see how the string is done.
Why do we want to see a string type?
Because we want to print it. If you want to see why, just let's see the output first. So you want to print it like this. See, 9x squared plus 4x plus 2. Okay. In order to print it like this, you would like to convert it to string first. Okay. So what is this program doing is the following. Basically, we enter the extremum of x, the extremum of y, and we enter whether it's minimum or maximum. And the program tells us whether it's correct or incorrect or whatever. So let's say I'm making wrong guesses now. So enter the x value of the extremum point. I'm saying the x value is 5, the y value is 9, and I'm saying this is minimum. And it's saying no, it's false. It's not 5, it's 0 minus 0.22. No, y is not 9, it's 1.56. And the min-max value is correct because this is a minimum, okay? If you want to continue, you press yes. Otherwise, you press no. I don't want to continue, and you do the same stuff. But toString is just to convert the polynomial to this stuff here. So we can print it in this way, okay? So let's see how it's going. It's very simple, basically. So toString is doing the following thing. Initially, the return string is the following one. We convert my a to string using I to a from string utilities, plus we add this x squared, okay? But there is a problem. Where's the problem? If I ask you, Jim, how old are you? Are you going to say I'm plus 19? No. Okay. And the computer, when we write numbers as integers, it's not, if it's a positive, the plus sign is assumed. It's not being written. That's why we should do the following stuff. If it's negative, if you say, okay, what's the value of this guy, you might say minus 19. But if it's positive, you say 19. That's why, initially, if the value of x is, of a, the coefficient a is positive, you shouldn't write it. Okay, you see it here, 3x squared minus 2x. If it's negative, it's going to be written accordingly. But the value of this plus 3 should be written. Okay? And let's see how we do it. So, if the value is negative, just from this returns 3, plus equal, you know what plus is doing, it just concatenates two strings. So, initially, we wrote a plus x squared, meaning we wrote this first part here of the polynomial, this monom here. Afterwards, we go with b. If b is smaller than 0, very nice. Just convert b to a string, add it, plus x. So we've done this stuff, bx. But what if b is positive? Then we want to write the plus sign, because the plus sign is not written. Okay? If we don't write it, and if the value of b is 2, we will have 3x squared, 2x, but now we want to write plus 2x. That's why we write plus. Okay, since the negative values are written, and if you don't have a sign, they are assumed to be, that's why we write them here. So plus, then we convert my b to integer, to a string, and write x. And we do the same stuff with c. If c is greater than 0, if it's the case as it is the case here, we write the plus sign, and we convert c to integer. Okay. Otherwise, if c is not greater than 0, we just write c as it is, because the minus sign will be there. And finally, we return the string. So here plus equal just concatenates. Here we write the first part of the polynomial, the x squared part, then the x part, and finally we just append in the end, concatenate the c part here, okay, with one of those two ifs. And in the end we return the string. So this is how it's done. So if you see the two-string function in your life, it's something like this, okay? Now let's run the program again. So with the two-string function, those numbers 9, 7, 6 are generated randomly, okay? And we use the two-string function to write this part here, as we saw. So let's find the extreme value. Now I want to find correct values. How are we going to find x? X is going to be, so a is 9, b is 7, c is 6 here. So the extreme value here is going to be what? Minus b divided by 2a. So it's 7 divided by 18. 7 divided by 18. Minus, exactly, which is going to be minus 0. Blah, blah, blah. So I'm going to write it minus 0.38888. How many 8s do we have? 1, 2, 3, 5. Usually it takes 6 digits only, by default. Let's give a wrong value for y. Let's say 5. And is this a minimum or maximum? A is greater than 0. This is minimum. That's why let's write minimum. You see that extreme is, it's false. Why it's false? I don't know, because of the precision issues. I wrote exactly the same number, but it says it's false. This is because of precision issues. Okay. The y value is also false. I gave 5, but it's 4.63. But the extreme, the minimum, whether it's a minimum or maximum, it's correct, and it was a minimum. Do you want to continue? Yes. So I have another polynomial. This is cuter one. A is b. A is 5. B is how much?
0.
It's 0. We don't have it. And remember, a shouldn't be 0, because if a is 0, it's not a quadratic function. Okay? That's why a shouldn't be a 0. So what's the minimum here? X minus b over 2a. X is 0, so 0 over 10 is how much? It's 0. So x is 0. What's the value of y? It's 8. I mean, in order to find the x value, we just apply this formula. We see that b is 0, minus b over 2a. b is 0. 0 divided by 10 is 0. Then in order to find y, we just substitute x here. So x is 0. 5 multiplied by 0 squared is 0 plus 8. Y is 8. And this is again a minimum. I suppose everything is correct now. So yeah, the x value is correct, it's 0. The y value is also correct, it's 8. Min-max property of the point is minimum. Okay, I don't want to continue anymore. That's why I give no as an answer. This is it. Now let's see how this code is being done. We saw all of the headers. Now let's see the main part. Firstly, let's explain this function here, generate coefficients. It takes 3 parameters, references A, B, and C. Why do we take references? Because when this function is going to be finished, we want to see the changes in the main function, okay, the function that called this one. So what do we do here? We want to generate coefficients for numbers, random numbers for the coefficients A, B, and C of the polynomial. That's why we first define the random generator, or a variable for the random generator class. And we say that A is a random number between 1 and 9. It's not between 0 and 9, because if it's 0, it's not a quadratic function. B is a random number between 0 and 9. And C is also a random number between 0 and 9. But those are references, meaning when this function is going to finish, those values are not going to be erased. They're going to be seen in main. We don't send a copy of them, we send the exact data. We send them as references. This is important. Now let's go to the main function. We define 2 strings. One is comment and the other is min or max. Comment meaning that you give here yes or no. Do you want to continue or no? If you give yes, you continue. No, you don't continue. Min or max, you give whether it's a minimum or maximum. Then we define 3 variables, A, B, and C. Those are our corresponding coefficients of A, B, and C of the quadratic functions. And we define also 2 double variables. Those are the variables that you give as an input for the extreme values for x and y. Extreme x, extreme y. Initially, the command is yes. Okay? So while the command is yes, and command yes is equal to yes, this is true, we go inside. Generate coefficients, we call the function that we previously explained. And we send A, B, and C as parameters. We have, when the function is finished, we have 3 random numbers here for A, B, and C. Okay? We define a new polynomial, A, B, and C. And we defined how it works, okay? The constructor is going to put my A to A, my B to B, my B to C, my C to C, private data. Then we print polynomial is poly to string. We print it. We call the function to string. Okay. Maybe it will be good if we do something like this. Run it. So, enter. We are here. Now we are asking this one. Enter the x value of extremum point calculated. We print this guy. And I'm giving the extreme of x. Let's say I'm giving something wrong. Let's say it's 5. And I'm reading here, seeing extreme x. Now I'm saying enter the y value, and I'm reading the y value. Let's say the y value is 10. I'm making numbers. They're going to be wrong. Afterwards, it's asking me to enter whether extreme point is the minimum or maximum. Let's say I'm saying maximum. When I say maximum, I read the maximum, and then I go here. I check. Well, if the extreme x that I gave as an input is equal to the extreme of point of the real, the extreme point of the polynomial, then I'm going to print the x value is correct. Otherwise, if it's not, and it was the case, I did it, I'm going to print the x value of the extreme point is false. The true value is the following one. So basically, we printed this part here. So, the x value of extreme point is false, extreme is minus 4.5, and I gave 5 as an input. They're not equal. So afterwards, we continue. I check whether the extreme value of y is equal to the real extreme value of y, the extreme y that I gave. If they are real, if they are the same, I'm printing that it's correct. I'm printing the extreme y. Otherwise, if they're not the same, I'm printing this stuff, that the value I gave is false, and the real extreme value is this much. polypoint extremum of y. So I print here, the y value of extremum point is false, I gave 10, and the real one is minus 13.25. And finally, I check min or max. Okay. For min or max, if you remember here, I gave maximum, I think. But the problem is, and then we check. If the min or max that I gave is equal to that of the polynomial of the quadratic functions, then I print that, yeah, the min-max property is correct. Otherwise, if it's not correct, I print this stuff here. Min-max property of point is false, and the real value is this much. So let me check. Min-max point is false because I gave maximum, and the extreme point is minimum. Okay. Of course, it's a minimum because we have a being 1, and 1 is greater than 0. So we have a minimum according to the formula here. Now we are finished, and I'm reading the command. Do you want to continue? Yes or no? Do you want to continue? Yes or no? And I should read the command. Yeah, let's say I'm saying yes. I read the yes. When I read yes, I go to the beginning of this while. And we're asking whether yes is equal to yes. Yes, it is. Again, we're generating coefficients, calling this function a, b, and c. Now let's give true values. Give me, what's the value of x? Now, minus b over 2a. Come on. I'm not going to give it them. We can stay for the rest of our life here. It is 6 over 16.
Yeah.
So it's minus 3 over 8. And how much is that? Because we have to give it as double. Unfortunately, you can write, by the way,
0.375.
0 point minus,
Yeah,
minus
0.
0.375. Is this correct? Okay. Now for y, just substitute this to this formula. How much is that? But be careful. I mean, this is minus, okay? Let's try to make all of them true this time.
Minus 0.125.
Let's write it. Minus 0.125. Okay, let's write. Is this a minimum or maximum? A is greater than 0, so this is minimum. Let's see. Yeah, we were correct. The x value of extreme point is correct. The y value of the extremum point is correct. And the min-max property is also correct. Okay? So basically, when we gave all the inputs here, we checked if extreme x is equal to extreme x, real x, then we write the x value is correct. If this is correct, this else is not going to be correct. Now let's check for the y. If the extreme y that we gave is equal to the real extreme y, then we print the y value of extremum is correct, and we print it. Okay, this else is not going to be executed since this was correct. And finally, if the min or max value is the real minimum or maximum value of the polynomial, we are going to print that the min-max property is correct, and we are printing it. Otherwise, we print something else, but it was not the case. Now I don't want to continue, that's why I give no as an input, and I'm finished. So when I gave no, I'm asking no is equal to yes, this is false. So I go here, I return 0, and this is it. Any questions about the program? I hope you understood it. Yeah. If there are no questions about the program, then let's continue with the date class. It's an interesting class. It might be complicated for you, but of course we don't expect and don't ask from you to understand it from scratch. So remove everything about this stuff. Go to your folders that I sent to you and open the date class. Copy paste this guy, those here. Just paste it to the solution folder.
Dates.
Date, not date 2, only date. It's not date 2, only date. And add the existing items. So we are adding date sample, date age, and date CPP. Okay, this is a new class. This is about dates. And let's see what is this guy doing. And I'm telling you, the implementation is hard. Probably, in order to understand this class, you should take also the CS204 course. Okay, remember something which is called operator overloading. Because you have seen the operators like A++, C++, C+ equal, and so on. We're going to do the same things for the date class, but these are not part of the CS201. If we meet in CS204, Advanced Programming course, then you will have it. I mean, you will understand how this class works. Otherwise, you should just know how to use the functions here and how functions work, nothing else. So, let's see what the date class is about. So this is class date. I think it's in capital D. It's not important, yeah. Uppercase D. And let's see what do we have here. Let's go to the private data first. When we are talking about a certain date, we're talking the day, the month, and the year. Okay, so we have my day, my month, my year. Those are integers. So private data are those ones. Usually you keep variables as private data. So private, those are all integers. My day, my month, and what else? My year. There's also a function called check date, and this function is called to make sure that the date is valid, meaning I don't give negative numbers for any of them, or I don't give 30 days to February, and so on, okay? Because it doesn't make sense that to say I'm born in the -3rd of February 2016. So these are the private data. Let's see the public data, the most important ones I'm going to write. There are plenty of them. We are not going to use all of them, but I'm going to write the most important ones, or the ones that we are going to use. Okay. Again, when we declare a new variable of class date, a new type of class date, the first thing that we're going to do is to call the constructors. The most obvious constructor is this one. So when I declare, let's say, date, my date, and I give 3/6/2016, basically I'm calling this constructor. Integer 3, this is for the month. Day is the 6th. Year is 2016, okay? And basically, my date is put to be M, my month is M, my day is D, and my year is Y. This is what the constructor is doing, okay? This is the most important constructor here. So date, and I give for 3 parameters, A, B, and C, or in our case, M, D, and Y. Remember that the first parameter we give is the month, then the day, and then the year. And those my day, my month, my year are set correspondingly. We can give something like this, long days. Meaning I can give like a very big integer, a long integer, and I can say, okay, 1 million. And it starts from 1st January, year 1, up until how many days? 1 million days. Okay, it might be 2057, for instance. But we don't need it, okay? With default value, I think that if we call this constructor here, if I say date and only my date with no parameters, I think it's 1st January, year 1, okay? It's interesting to know that we don't start from the year 0. The counting started from year 1, okay? That's why you had the problems of 2000, 2001. So basically 2000 was not the new millennium. It was 2001. But it's not our matter of concern. What do we have else? We have a function called month. It returns the month, okay? Meaning it returns it as an integer. Okay, 3, 5, 12, or whatever. So month. Then we have day. Now, I mean, about the year, since you might, I suppose, when I mean like your age, younger than you, I think was 14 or so, when I started to program, maybe less, I'm not sure. But it was a kind of interesting to me and weird to me, why do we start counting from 0? Okay? But now I understand why, and should get used with that. What do you think? When the calendar was set, should we have started from date 0, 1st January, date 0, year 0? Is this more logical or what? What do you think? Or maybe year 1, 1st January of year 1. And after 1 year it will be year 2. From 0, from 1. What do you think? I mean, it's like this. This is 1 centimeters. This is 2. Do we start counting from 1 or from 0? From 0. That's why in programming we start counting from 0. Okay? Never mind about that again. So, the other function is day. It returns the day. We have the year. It returns the current year. Days in returns number of days in that particular month. So, another function is days in. Remember, all of those are part of the member functions of the class date. We are going to use them. Day name returns Monday, Tuesday, Thursday. It's a string. So remember this day name because we are going to use it in a program. That's why I'm going to underline it. Maybe I should underline it in red. So you're not. I mean, the functions are obvious, straightforward. Remember day name because we are going to use that. Month name. Not sure whether I'm going to use today. You might have a homework with the date class, by the way. You might have it. Absolute, I'm not going to write it. Number of days is 1st of AD, after the Christ. Okay? How many days have passed? To string, to convert the date to string, something similar with the polynomial stuff that we saw. We don't need that. Days remaining returns how many days remain in this month. Equal for dates. I mean, with this particular class takes another date and compares whether the dates are equal. Okay, that should be exactly the same, the day, the month, and the year. If it's correct, if they are the same, return true. Otherwise, return false. Thus, you might know. Okay, if the year is the same, we check the month. If the month is the same, we check the day. Okay. And so there's something interesting here. Operator plus plus. So we have operator plus plus. When we have integer numbers, what do we do with plus plus? By how much? By 1. Here also, we increment the date by 1 day. But pay attention. So if today is 23rd of November 2016, and if increment it by 1, it's going to be 24th of November. But if this is 30th of November, and November has only 30 days, so what's going to be the next day? 1st of December 2016. What if today's date is 31st of December 2016 and I'm trying to increment it? What I'm going to get? 1st January 2017. Okay, so this is how the operator plus plus is working. Basically, you can, with programming, you can define your own operator and apply it to date. So operator plus plus, I'm going to underline it, is incrementing it by 1 day. We have correspondingly, operator minus minus is doing the opposite thing. So operator minus minus is decrementing the date by 1 day. Remember also operator minus minus. So if today is 1st of January 2017, and if I apply minus minus, it's going 31st of December 2016. Exactly. What do we have else? Plus equal. And you take an integer, a Greek integer. Let's say today's date is 23rd of November 2016, and I want to add 5 million days to this date, or let's say 1,000 days to this date. It's going to be somewhere 2018 probably, no, 2019, 20. Okay? So I'm adding those days to the date and getting another date. And always when I say date, I mean day, month, year. Minus equal, I'm subtracting. If I subtract like 365 days from this year, I'm going to get 23rd of November 2015. Okay? Set here if you want to set the year. This is it. I mean, this is an interesting class. You just should know how they work. There are some other stuff that you should know. Like this one. Those, I mean, the class finished here. We have semicolon. We don't have any member functions. We have other functions that are defined outside of the class, and those are not member functions. Okay? So we finished with the class. Those were the most important functions, member functions, private or public, whatever. And member functions meaning that they are defined inside the class. All class date. All of the variables of type date have these properties, okay? And we have other functions that are defined outside and they don't have it. For instance, we have something like this. Let's say operator minus, but we have two operators minus, as you can see. One of them takes a date and another date, and what it's doing, it's subtracting the first date minus the second date. For instance, if I say today is 23rd of November, and it's returning a long, meaning it's returning a long variable, an integer. For instance, if I say if this date here is 23rd of November 2016, and 2016, yes, and this date here is 23rd of November 2015, I'm going to return 365 days. Okay, so remember this function because we are going to use it. We have operator minus. We return long, which is an integer. And we have date. We take it as a parameter. Right hand side, RHS, left hand side first. LHS means left hand side. And date, parameter, right hand side, RHS. So we return how many days are there in between those two dates. Okay, but in terms of dates. What else? We have this operator, OStream. So we have operator, meaning we can print the date. Okay, you remember with the robot function, in order to print something, we use show message, blah blah blah, get input. Okay, but we can print the date like this. Basically, if I have, so the name of the class is date. This is the type. It's like saying integer A. So this is date, this is the type, and this is the name of my variable. Let's say it's my date. And let's say I give like 8, 11, 19, 90. Or no, yeah. Okay, so this is my date. If I define another date and say today, I might give something like 11. I give the month first, the day, 23rd, and the year, 2016. And if I use something like my date, no, today, minus my day, my date. Basically, I'm subtracting today to my date. So left-hand side is going to be today. Right-hand side is going to be my date. And I'm subtracting them, and I'm returning how many days are in between. Okay, so there might be how many days? Let's say that 12,365 days. But I'm returning the number of days. Okay? It will be clearer in a while. And we have also the operators, equal, not equal, greater, smaller. And you might assume, you can figure out what they are talking about. So this is the class date, the member functions and the functions that are defined outside. If you want to see the concrete definitions of the functions, how they are written, you can go and check the date CPP here. Probably you're not going to understand it, but you might understand like 5-10% of it. Anyway, we don't care about that. Let's see what are we going to do with this class. In order to use the date class, we should include it, as we have seen already many times. So, enter a year. Let's see what is this guy doing. This function, this program, what is this doing? I'm entering a year. Let's say I'm entering 2016, this year. I forgot the system pause or ignore stuff. So for your homeworks, don't use system pause, please. Use C in ignore and C in get. I'm just using it to make it faster. Okay, so the year is 2016. We are trying to find months that end on Sundays in year 2016. And only 2 months end on Sunday for 2016. They are January and July. If you don't trust me, let's check the calendar. So, January and 31st of January was Sunday, Pazartesi in Turkish. That's why we printed it. July, how do you say Turkish July? Temmuz, I think. So Temmuz also, July ended on Sunday. That's why we printed it. And no other month, as you can see, ended on Sunday. Again, let's try another year, 2015. Only May ended, 30th of May, I think, ended in Sunday. And no other month ended in Sunday. So this is what our function is doing, our program is doing. It, for a given year, it tells which month ended on Sunday. Let's see how did we do this stuff. We define the year, we define the day. Okay? Year will be our input, so we give our input here. And we start from the 1st of January of that year. So when I give 2016, I start from 1st of January 2016. Okay? And I'm printing months that end on Sunday in year 2016. And I start from 1 till 12, since we have 12 months. And I'm checking each month one by one. Did it end in Sunday or not? And I'm going. Now see, so there's something interesting. D is equal to D plus D point days in. Days in is a function that returns the number of days that particular month is. So initially we were in January, first month. And first month has 31 days. Okay? And days in returns 31. When I say D plus, this is the operator plus. I didn't write it. I think it was a member function. But anyway, to the initial date D, we add 31 days, because January has 31. So 1st of January, when we add 31 days, what did it become? 32 January? Days in is 31, since January has 31 days. And we add to our date 31 days. So what did it become?
1st February.
1st February, not 32 of January, 32nd of January, okay? So up until here it's 1st of February. Then we take one day, what did it become? 31st of January, okay? Is this clear? Is this clear or not? We go, now you remember the string function? We take the day name. We take it and we check whether it's Sunday. If it's Sunday, we say yes, print the month name, and month name is here. It's also it's a member function. We print it. And we increment d++. D++, what was doing? It was incrementing the day by 1 day. So, here remember we went 31st of January, okay? D++, one more day, it's 1st of February, okay? We go here. This is going to be repeated for 12 times. Now d is equal to d plus, how many days does February have? Let's say 28. Yeah, 28. So we are 1st of February, and let's say that month has 28 days, that February, that year has 28 days of that particular year. And I add days in. So it's 1st of February, and I add 28 days. What is it going to become? 1st of March. Minus 1 day, it's going to become 28th of February. Now I take the day name of the 28th of February and check whether it's Sunday. If it is Sunday, then I print the month name. Again, I increment it by 1, so it's 1st of March. I go here. March has 31 days, meaning up until here we are 1st of April. Minus 1, it's 31st of March. I take the day name, check whether it's Sunday. If it's Sunday, I print it, I increment it, and so on, okay? I repeat this loop 12 times for 12 months. And afterwards, the program finishes. So let's try it again. Just give me a year which is interesting. I mean, not 2015. Which year? 20? 2K20. So only May. 2K20 means 2020. K kilo. Your job, you have 5 minutes. This will be counted your activity. Your job is the following. You should write a program that will calculate, 1, how many days have passed since you were born up until today, and 2, how many seconds. Basically, I want you to tell me how many seconds you are old. Those data that I just gave it to you should be enough for that stuff. Okay, you have 5 minutes to do it. We will be back after 5 minutes.